Let's now talk about acid and base dilution. In this topic, there will be no new concepts introduced. Instead, we're going to review dilution from Chemistry 2202 and mix it with the concepts of acids and bases learned to date. Most solutions bought for laboratories are in the concentrated form. These purchased solutions are then diluted to the known concentrations that you use in the lab. When a solution is diluted, only the amount of solvent is increased. Therefore, the number of moles of solute in the initial solution is equal to the number of moles in the final solution. For instance, if I decided to make myself a glass of Kool-Aid and found that it was still sugary, I could dilute it down by adding more water. However, the amount of Kool-Aid in the initial solution, or the concentrated solution, is the same as the amount of Kool-Aid in the diluted, or final solution. Recall from Chemistry 2202 that the dilution formula is CiVi equals CFVF. While this was given to you in Chemistry 2202, it will not be provided in Chemistry 3202 or IB. This can also be written as C1V1 equals C2V2. Recall that the initial solution is the concentrated solution and the final solution is the diluted solution. This may be important for deciphering further examples. Let's work through several examples. Calculate the pH of a solution formed by the dilution of 250 milliliters of a 1 molar barium hydroxide solution to a final volume of 150 milliliters. First, we need to recall from Science 1206 the formula for barium hydroxide. That would be BaOH2, aqueous. Also, realize that this is both an ionic compound and a strong base, so it will dissociate into Ba2 positive and 2OH minus. Off to the side, it may also be useful to write out Ci, Vi, Cf, and Vf to help you decipher the example. It says, calculate the concentration of a solution formed by the dilution of, meaning whatever comes afterwards must be our initial solution if we are then diluting it. So we have an initial volume of 25.0 milliliters, an initial concentration of 1.00 molar, to a final volume of 150 milliliters, meaning we first need to find the final concentration before we can find the final pH. CiVi equals CFVF, so we have 1 molar times 25 milliliters equals Cf times 150 milliliters. To get the final volume, we have to divide by 150 milliliters on both sides. Notice that when we do this, we have milliliters over milliliters, so it's okay that we did not convert it to liters because the milliliters will cancel out. When we do so, we are going to get a final concentration of 0.167 molar. This would be all you have been responsible for in Chemistry 2202. However, in this section, we're looking for the pH. Notice that we've just found the concentration, finally, of barium hydroxide, so 0.167 molar. Notice that the relationship between these two is a 1-to-2 relationship, and we have twice as much hydroxide. So to get the concentration of hydroxide, we must multiply this by 2. 0.334 molar. Also remember that there is no one formula that connects pH and pOH. So this was step 1. Step 2, I can find the pOH by doing negative log of OH minus, which is negative log of 0.334. Also remember your significant figure rules. We have 3 significant figures here, So I should have a POH with 3 decimal places. Then finally, and I apologize, I ran out of room here, so I'm going to write this down here. I can find the pH by taking the POH away from 14. So 0.476. Notice I added as many decimal places after the 14 as I had for the POH, and this is 13.524. Also remember that barium hydroxide we said was a strong base, so we would expect that the final pH would be somewhere between 12 and 14. We'll also do this here now, and we can move on to the next example. You have a 0.5 molar solution of HBr. If you were to use 20 milliliters of this to make a solution of 0.02 molar hydrobromic acid, what is the final volume? Recall that HBr, or hydrobromic acid, is a strong acid that just dissociates out into H positive and Br minus. We'll also write out CiVi, CFVF off to the side. This might not be something that you need to do anymore with practice, but if you do, it's quite all right. It says that you have a 0.5 molar solution of HBr, and you're using this to make a new solution with a lower concentration. That means the lower concentration is the diluted form, and the 0.5 molar is the concentrated or initial form. We're also using 20 milliliters of this solution to make the diluted solution, and we've been asked for the final volume. So CiVi equals CFVF. 0.5 molar times 20 milliliters equals 0.02 molar times Vi. To get the initial volume, we have to divide both sides by 0.0200 molar to get that to cancel out with the Vi. Notice that all of our variables here have 3 significant figures. So we get an answer, and keeping in mind that molar and molar cancels out, so we're going to be left with an answer in milliliters. Always be careful because the question may specifically ask for milliliters or liters. So that's VF, our final volume is 500 milliliters. Notice that I've placed the decimal place after to ensure that those 2 zeros are significant. You could also write it as 0.500 liters. Let's try a new example. How much 2 molar sodium hydroxide would you use to make 1.50 liters of a 0.05 molar sodium hydroxide solution? So we have CiVi, CFVF. It says, how much 2 molar would you use? If you are using that, that must be the initial concentration. To make. So everything else that comes after must be the diluted solution if you've made it. We have 1.50 liters of a 0.0500 molar solution. So here we're looking for the initial volume. CiVi equals CFVF. We have a 2 molar initial concentration times the initial volume equals 0.05 molar times 1.50 liters. Here notice that volume has been given to us in liters, and we're looking for another volume. So our answer this time, as opposed to the last question, will be in liters already. Also notice that each number has 3 significant figures, so our answer should also have 3 significant figures. And that would be 0.0375 liters. Our final example is if 25 milliliters of hydrochloric acid solution with a pH of 2 is used to make 800 milliliters of a diluted hydrochloric acid solution, what is the new concentration of hydrochloric acid and the new pH? So we have CiVi equals CFBF. So let's find each one of these variables now. We have 25 milliliters of a solution is used to make. So this is our initial volume. And we're making a new 800 milliliter solution. We're also looking for the final concentration. We haven't explicitly been told the initial concentration, but we have been told that it has a pH of 2. We're talking about a hydrochloric acid solution. And remember that hydrochloric acid is a strong acid, which dissociates out 100% into H positive and Cl negative. Also remember that H positive can also be written as H3O positive. So I can find the concentration of H positive or H3O positive by using 10 to the negative pH, or 10 to the negative 2.00. Remember your rules for significant figures. We have 2 decimal places, so we'll need 2 significant figures. So this would be 0.010 molar. Now we can use the formula CiVi equals CFVF to solve for the new concentration. 0.010 molar times 25 milliliters equals CF times 800 milliliters. Notice that both volumes are in milliliters, so we don't need to convert it to liters. If you do, that's okay though. That cancels to give us a final concentration of 0.01 times 25 divided by 800, 0.00031 molar. Notice that we have in this question 2 significant figures, 3 significant figures, 4 significant figures, the lowest being 2. We aren't done the question yet though, because it also asked us for the final pH. pH is equal to negative log of H positive or H3O positive, depending on what we have. So it's negative log of 0.00031. Notice we have 2 significant figures, so we need to have 2 decimal places. And this would be 3.51. Notice here that hydrochloric acid is a strong acid, and in this case we have a pH of greater than 0 to 2, which means that this strong acid has been significantly diluted. Hopefully this review is satisfactory enough for you to now work on the dilution worksheet. Good luck!